Hello boys, I hope you had a nice weekend. I hope we got out and hope you enjoyed a bit of snow, if you got snow. What we're going to be learning then today is we're going to be learning to use trigonometry to calculate the area of a triangle. Okay, so we're going to use trigonometry to calculate the area of a triangle. What I'm going to do first is I'm going to show you where it came from. So it's in the log tables. So this is the formula that we're given. Half AB sine C is the area of a triangle. That's in your log table, so you don't have to learn it off. So I'm just going to quickly, just for yourselves, run through where that formula comes from, just for anyone who might be interested. And then I'm going to run through 3 examples, and I'm going to give you some questions to do then, okay? So I'm going to first of all run through where that came from. So if I just draw out a triangle, so this side is A, we've B, and we've angle C. So always, lads, when we're looking for the area of a triangle and we're going to be using this formula, it's always going to be 2 lengths with the angle in between, okay? It has to be 2 lengths with the angle in between, always. So this is the first time then that we don't need a right angle triangle. So for Pythagoras' theorem and the sine, cos and tan that we've been using so far is always only when we have a right angle triangle. So this area of a triangle then can be used on any triangle, okay, once we have 2 lengths and the angle in between. So I'm just going to show you where the formula comes from. So from this then, if I cut this triangle in 2, okay, I have my right angle there, and I'm going to call this length H, okay? So then we know that A is our hypotenuse, going back to our sine, cos and tan, and H then is our opposite. So we know that sine is equal to opposite over hypotenuse, cos is equal to adjacent over hypotenuse, and tan is equal to opposite over adjacent. Okay, so if we're trying to find what H is here, okay, we know that we're using opposite and adjacent, so we're going to use sine C is equal to H over A. So if we're trying to find what H is, we're going to multiply across by A. So we know that A sine C is equal to H, okay? Then we know for any triangle how to find the area of a triangle when we're given the perpendicular height is half the base by the perpendicular height, okay? So it's half the base, so half the base, which is B here, so it's this length here, it's the base, so half of B, and it's by the perpendicular height, which is H here. So we know that H is equal to A sine C, so A sine C, okay? So then that's the equal area. So subbing in then for our perpendicular height, and then if we rewrite it in alphabetical order, so half AB sine C is equal to the area of the triangle, okay? So that's just for anyone who's interested in how the formula came about, okay, where it came from. So now I'm going to have a look at question 5, okay? Just looking at question 5 then on page 529. We're given this triangle and we're asked to find the area of the triangle correct 2 decimal places, okay? So we know the angle and we need to know the 2 lengths, okay? So we need to know the 2 lengths and the angle in between. As this line and this line just means that they're equal, okay? So if we have the same symbol on both sides of a triangle, it just means that they're equal. So this length is 10 and this is also 10, okay? So it's an isosceles triangle. So then we know that the area is equal to half the base, or half AB sine C, okay? So area then is equal to half of AB, which is 10 by 10 sine C, which is 70. Okay, so half of 10 is 5 by 10 is 50 sine 70. So if we put that into our calculator then, (50 sine 70) is 46.984631. Okay, so after 2 decimal places, 1, 2, so it's 46.98 squared units. Is that okay, lads? So it's not too difficult, this questionnaire. So the hardest part was knowing that these symbols mean that they're the same length, okay? So again, half AB sine C. So half A is 10, B is 10. Doesn't matter which you call A and which you call B. Sine 70. So 10 by 10 is 100. Half it is 50. Sine 70. Stick that into the calculator, and this is my answer, 46.984631. And when I round it off, then it's 46.98 squared units to 2 decimal places. I risk squared units because the answer has to be squared because I'm finding area, and I'm not sure whether it's in meters, centimeters, millimeters, what. Okay, so I just left it squared units. Is that okay? So the next question we're going to look at is question 7 on page 529. So in a triangle X, Y, and Z, XY is 9 centimeters, XZ is 18.4 centimeters, and the angle of XYZ is 82 degrees. Calculate to the nearest square centimeter the area of the triangle X, Y, and Z. So again, I'm just going to draw this out rough. So, X, Y, and Z, and I know that XY is 9 centimeters. I know that XZ is 18.4 centimeters, and I know that the angle YXZ, which is this angle here, so 82 degrees. Okay, so it was start at Y, go up to X, go down to Z. So it's the angle in between then is what we're talking about. So we're trying to find the area of the triangle. So again, area is equal to half AB sine C. So lads, I would always draw out these triangles, okay? I think it's easier to do them when we see them, right? So I always try them out to make sure we're picking out the correct information. Area then is equal to half of 18.4 by 9 sine 82. So area then is equal to half of 18.4 multiplied by 9 is 82.8 sine 82. Area then is equal to 82.8 sine 82 equals 81.994196, and ask for the nearest centimeter. So area then is equal to 82 centimeters squared. Is that okay? So lads, it'd be smart now to take those down so you can pause the video and take them down, okay? So then lads, just the last example I'm going to look at then is question 11, okay? So question 11. In the triangle A, B and C, the length of AB is 10 centimeters, BC is 8 centimeters, and cos the angle ABC is equal to 5/13. Part I, by drawing a suitable triangle, find sine angle A, B and C. Okay, so I'm going to draw out the first angle there. Okay, so I'm going to draw a triangle. So that there is my angle A, B and C. So then it tells me that the length of AB is 10 centimeters and the length of BC is 8 centimeters. And it also tells me that cos of the angle ABC is equal to 5/13. So the angle A to B to C. So if I start at A, I come down to B and I go over to C. So it's this angle here that they're talking about. Okay, so then I know that the angle ABC is equal to cos inverse 5/13. So angle A, B and C is equal to shift cos 5/13. 67.38 degrees. So when I put in the second function cos 5/13, I get 67.38013505. So just to get a better answer, closer. So then ask the sine of the angle ABC then. So sine 67.38013505 is equal to 12/13. So that's part I. Part I then asks to find the area of the triangle. So area then is equal to half AB sine C equals a half of 10 by 8 sine C, then we found to be 12/13. Area then is equal to 40, so half 10 is 5 by 8 is 40. Multiply it by 12/13. And we are getting 36.923. The question doesn't specify, so I'm going to leave that centimeters squared. Okay. There we are. So you might need to go back on that. Remember, pause and take it down if you need to. So I drew out my triangle. I put in the information I knew. I told us that cos this angle here is equal to 5/13. So inverse cos then of 5/13 told me that the angle was 67.38013505. So again, remember we want to go into at least 4 decimal places to get an accurate value then later on. So sine ABC then is what asks us to find. So sine 67.3801353505 is equal to 12 over 13. And then part 2 asks us to find the area. So the area of the triangle is equal to half AB sine C. So again, I'm always writing in my formula. So half of A, which I let be 10, and B by 8, doesn't matter which way I write them, by sine C we already worked out as 12 over 13. And then when I stick that all into the calculator, I get 36.923 centimeters squared. So lads, I hope those questions are okay for you. So if you've any questions or you're stuck, don't be afraid to ask and let us know, okay? We won't bite, we'll give you a hand, okay? So don't sit there and not know, right? So for today's questions then, we'll just look at page 529 plus 530, exercise 17.5, questions 4, 6, 8, and 10. Okay, so you should get them done in the 45 minutes that you've left in class, a little less. Alright, so you should get all them done. So give those a go. Again, if you're stuck, let us know, okay? And don't forget to upload them, lads. You really, 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 really need to be keeping on top of all your work. So make sure you give those questions a go and upload them so you remember the drill. The picture must be of good quality. Correct them before you hand them up. And if you're stuck or you want us to go through any of those questions, make sure you let us know, okay? Thanks, lads.